gonna tell you about periodicity of decimals. Have you ever heard about recurring digits? Recurring numbers? A recurring number is any number which follows the same pattern after decimal point till infinity. For example, 0.01010101 will take its position and go on forever without stopping. But we write these numbers as a special way because we cannot write infinite number of digits. So we write it at 0.01 bar. This bar represents that it is a recurring decimal, and a recurring decimal is non-terminating. It will never terminate. So this time here I will try to convert unit fractions into recurring decimals, and I will see that what kind of patterns they make. This discovery I made recently. There might be a law about it, but I have not heard it. For example, let's take the easiest decimal, 1 by 2. Is it a recurring decimal? No, it's 0.5. Why is it not recurring? Because the base is a multiple of 2. Similarly, if you see 1 by 5, it is also not recurring. It is 0.2. Why it is not recurring? Because it is a base is the multiple of 5. You are saying that these two numbers are 2 and 5. So let's take a longer number. Let's take 1 by 1000. Or let's take 1 by 800. It is also not a recurring decimal. It is 0.00125. 0.00125. So they're saying again, this is also not a recurring. Why are you telling this, Manas? I am saying why this is not recurring because we can break 800 into 2 to the power 3 to the power 5 into 2 to the power 5 into 5 to the power 2. This is also a multiple of only prime numbers 2 and 5. 800 is the multiple of 2 and 5. It's just a its prime factorization gives 2 and 5 only as its products. So these numbers will never reoccur because any number with its base as a multiple of 2 or 5 will never reoccur. Only 2 or 5 will never reoccur. So let's talk about other decimals. For example, 1 by 3. What is 1 by 3? It's 0.3333 or else it is 0.3. Means it is a recurring decimal, but it has the periodicity of only 1. What is a periodicity? It's the number of digits, number of places in which a recurring decimal changes its place, means repeats its place. So the periodicity of this is 1. Similarly, of 2 by 3, the periodicity is 0.6. It is equals to 0.6, which is 1. So, and a very interesting case you can see, what is 3 by 3? Is equals to 1. But as in mathematics, there are some common, very minute mistakes which cannot, but it is also equals to 0.9 bar. Means this number is limiting to 1. It is not 1 absolutely. So 3 by 3 is equals to 1 if we take the conventionally, but it is very difficult to convert this very difficult to convert this directly to 1. So it is 0.99999, which will go on forever, which is about means there's a difference of 0. Means 1 to the power what infinity, 0.1 to the power infinity. The difference of 0.1 to the power infinity between 1 and this. So there, if we take 3 by 3 also, it comes 0.9. So we cannot see any special pattern when the number has periodicity of 1. We will not take 1 by 4 because 4 is a multiple of 2. And then we have discussed our 5. We can take 6, but let's take a prime number because 6 is 1 by 2 into 1 by 3. Let's take a prime number, and this prime number will be 1 by 7. What is the special about 1 by 7? Why is 1 by 7 a considered number? 7 is a prime number. 1 by 7 equals to 0.142857. It is having a periodicity of 6. Similarly, 2 by 7. equals to 0.2855714 bar. 8 is also having a periodicity of 6. Any number means the fractional form of any number, means the decimal form of any number will have a periodicity which is 1 less, which can have the maximum periodicity of 1 less than the base of the fraction it came from. So if it is, the base is 7, the maximum periodicity which it can have is of 6 digits. Now let me show you something. What are the numbers after the decimal places which come in 1 by 7? These numbers are 1, 4, 2, 8, 5, 7. Let me arrange these. 1, 2, 4, 5, 7, 8. These are the numbers which come after 1 by 7. In this case, let's see which are the numbers. It is 2, there is 8, there is 5, there is 7, there is 1 and 4. So we are saying that if the base remains 7, the numbers of the decimal places will be these 6 numbers. There is no 3, there is no 6, and there is no 9. Even there is no 0. Why it is so? Multiply 1 by 7 to 10 to the power x, such that x is a very large number. X is not equal to infinity, because if x will turn out to be infinity, the number will become infinity, and we cannot divide any number from infinity. So now we'll try to convert this fraction, which equals to 10x by 7, to decimals. So what is the easiest way to do so? We will divide it. We will divide it. We'll divide it. So for dividing it, we'll use some common division method. So let's divide. What will come? 7. I'm just writing the numbers. Then 30 minus 28, 4. Then next we go. It will be 20 minus 14, 2. Then there is 6. 60 minus 56. It will be 8. Next it will be 5. Then it will be 7. Then it will be, again it will come 1. Then it will come 4. Then it will come 2. Then 8. Then 5. Then 7. Means it will be repeating after 1, 4, 2, 8, 5, 7. These digits will be repeating as it happened in 1 by 7. Why it happens so? Because 7 means they happen so because if you take 10 to the power x, x may be any number, and you mod it with 7, or if you divide it by 7, if you mod it by 7, the remainders will come as 3, 2, then there will be 3, 2, then it will be 6, then it will be 4, then it will be 5. Then it will be 5. These will be the remainder, and again 1. So these are the remainders which will come. And as we do in decimal, we try to add the zeros after it. Means we try to add some decimals after it. So we do 30, 20, 60, 40, 50, 10. And if we mod these number with 7, mod this number with 7, we get as 4, 2, 8, 5, 7 and 1. We never get a 3, we never get a 6, and we never get a 9, and even we never get a 0. That's why the decimal representation of 1 by 7 will never have these numbers. So as per my theory, I say 7. 7 is repellent to 3, 6, 9 and 0. And if you will see that in the decimal systems, these numbers are repellent for many times. These are many. If you do 1 by 13 also, and if you go 1 by 13 also, you go 1 by 17 also, and 1 by 19, you will see that the number of these numbers, the the number of these numbers after the decimal places will always be less than the other numbers. Means if there are two fives, if there are two fives, then there will be 1 3. There might be 1 3 at many places. So actually these numbers are not liked by the decimal system. So now let's come back to 1 by 7. If we see 1 by 7, it comes 1 4 2 8 5 7 bar. Let's take 2 by 7. 2 by 7, it comes as 2 8 5 7 1 4 bar. If we take 3 by 7, it comes as 4 2 8 5 7 bar. 2 8 5 7 1 bar. 2 8 5 7 1 bar. If we take 4 by 7, it will come as 5 7 1 4 2 8 bar. Means you see that these 6 numbers are being repeated. These 6 numbers are being repeated every time. 0 point, I mean, will be a point in 0. Why it is so? Means why is there repetition? Because like I told you that in any moment, at any time, 7 will not give a quotient in the terms of 3, 6, 9 or 0. Because 70 never comes there, 25 never comes there, because these numbers are not near to any multiple of 10. For example, let's take what is the nearest number to 10. Multiple of 7 nearest to 10 means before 10. It's 7, means it's 7 into 1. What is nearest to 20? It's 7 into 2. What is nearest to 30? It's 7 into 4. 1, 2, 4. What's nearest to 40? Then 50. Then 60. It is 7 to the power 5. It's 7 to 8. It's 7 to the power 11. You see the 11 also ends with 1 only. So if there comes, it's 50, it's 7 and there it's 8. And then again, next is 70. So the nearest to 70 is 70 itself. It's 70, it's 0. So we never take 0. If it's 0, then it will terminate. It's not happening. Let me show you two things. Let me tell you something else. We are seeing that, like, let me see. I can say you that I can find any number above here. Means if the numerator is any number, I can find it. I can find the number. Means I can find the decimal expansion of that number without using a calculator. And let me tell you how. Let me take as these numbers also repeating, as these numbers are only repeating. So in 2 by 7, in 3 by 7, in 4 by 7, in 5 by 7, in 5 by 7, and in 6 by 7, and 7 by 7 is equals to 1. You will see that these numbers will only make some pairs. For example, let me tell you, in 2 by 7, it's 0.285714. In 3 by 7, as I told you earlier, it's 0.428571. See down. Take a look at the first digit. Take a look at the first digit. Here it is 1, here it is 2, here it is 4. The first digit will be 5 at 4 by 7. You can check here also using the calculator, but I don't want to make the video too long. Then there will be 7 and there will be 8. And at last, there is no digit, there will be 0, because you can add as many zeros after you want, when you want, as you like, because it will remain 1 only. Then 0 has no value except a precision. So I can find any decimal expansion of any number with the denominator as 7. So let me give you a number. Let's take a number and like 1 2 3. 1 2 3 by 7. First of all, we have to convert this number into an improper fraction. We have to convert this improper fraction into a mixed fraction. So I think 119 is a multiple of 7. Yeah, it's 17 times 7. So 17 and up it comes 4 by 7. So what is this? 17. 17. So we can write this same as 17 point. What will be the first number 4 by 7? See, for 1, we'll write the numbers in descending order. It is 1, 2, 4, 5, 7 and 8. This will be of 1 by 7's first digit, this will be 2 by 7, this will be 3 by 7, this will be 4 by 7. So the first digit of 4 by 7 will be 5. So we'll write 17.5 and we'll continue the number in cyclic order below the bar. Like it will be 17.571428 bar. Why bar? Because it is not a terminating decimal. So which is the fifth number? It's 5 by 7. So the number it came as is 17.571428. So now let's take another example, which will be about 200 by 7. Let's take 200 by 7. What is the nearest multiple? What is the nearest multiple of 7? 200, which is just before 200. So I feel it's 196. So it is 196 4 by 7. Or let's take 201. Then 5 will come over. Let's take 201. It is 196 5 by 7. So in this case, let's convert this as decimal. 196 will stay as it is. After the decimal point, the number which is fifth. So here we can see 5 is fourth. What will be the first number after decimal in 5 by 7? It will be 7 itself. So here we will start following cyclicity and then write the number. It will be 0.771485 bar. After 5 again 7 will come, then 14285 and 714285, because it's just a recurring decimal. This is how we can do so. But the biggest question comes, why is this ascending order being followed? Let me ask a simple question. Will 1 by 2 in 1 by 7 and 2 by 7, which is greater? Obviously 2 by 7 is greater than 1 by 7. Similarly, if we take in ascending order, we say that 1 is smaller than 2. Similarly, 4 is greater than 2. So that's why even if we multiply these numbers, it will follow cyclicity. Because I told you as there will be never a quotient if 7 is divided by any multiple of 10. So this is why it will never be so.